Paul, why don't we dive into some of the important FinOps capabilities now? So I hear a lot about showbacks and chargebacks, okay? So people who may not be working with FinOps discipline for as long as you are, Dieter, people use it interchangeably. I know it's different. Can you spell it out for us? Chargebacks and showbacks.
Of course. So the tags that we mentioned or the labels that we mentioned earlier, right? They help with the cost attribution. So the very first, sort of like when you look at that from a crawl, walk, and run maturity perspective, right? And now to the FinOps Foundation is actually more and more using the pre-crawl. You don't do anything. How does this look like, right? So probably a showback is more of a crawl or walk maturity, where you show engineers, hey, this is how much you have spent, right? That then interconnects with budgets as well, right? Setting up a budget alert to let you know when your budget is in danger. Again, you don't want at the end of the month to get a notice, hey, I was 80,000 over. Now all I can do is just be sad about it and be hopeful for the next month. But let's say that your growth is so much steeper that an algorithm can determine that by the end of the month you will be 80,000 over, but it can determine that maybe 5 days into the month, right? So at that point, getting that budget alert is useful because now you can do something about it, right? Then chargebacks is again a different way of that accountability model, right? If each budget owner has a budget set, and then the cloud cost is being charged back to them, they can then make the best decisions on how to proceed. Let's say they want to roll out a new feature, but they don't have budget for that, right? If we side by side show a waste dashboard with opportunities to reduce cloud cost, right? So now you have a new feature of, let's say, $80,000, but then you have a couple of waste reduction opportunities of 50,000, 20,000, 10,000. Now this person can make choices. They can say like, okay, if I want this feature and I want to stay within budget, assuming, then I have these savings opportunities here that I can act on and share with my engineers. And once we have the savings, we can then roll out the feature in parallel. So on one side it will go up, and on the other one it will go down, but your budget overall will be not harmed.
Sounds easy to keep in mind, but Dieter, let me probe you on something, okay? Engineers, they are living with innovation. They don't like to be disciplined, all right? I was an engineer early in my career. I know once you're on a project, right, you want to use all the resources possible and some more. Okay, so where is this culture comes in place where, again, we want engineers to be innovative, but at the same time, to have that visibility and accountability in organization.
And I have to caution anyone that is becoming too procedural when it comes to doing things in the cloud, right? The strength of the cloud is that you can run experiments that were impossible in a data center, right? If I need to run a machine learning experiment that needs 100,000 cores for a couple of hours, that is extremely difficult to do in data centers, right? There are some known projects of protein folding where a data center has been built and then handed over from the protein folding company to the government, actually, to do some communications. So there are some precedents for that, but it's usually multi-year projects, right? We are looking at like 4 or 5 years for this entire thing, not 4 or 5 hours, right? So the strength of the cloud is not to help you save money. A lot of people get that perception wrong. When you compare apples to apples, in the cloud, someone else is carrying a pager, and they will be notified if there is an outage, right? That person needs to be paid, and that person is not within your company anymore, right? So cloud on average will have a little bit of a premium because someone else is doing that kind of work, right? Maintenance, patches, software updates, that kind of stuff. So the advantage of the cloud is really in that experimentation, to be able to do a machine learning experiment or something similar like that, right? 100,000 cores for a couple of hours. If it turns out that it works fine, Then what you can do is you can think of how to productize that experiment, right? Maybe from 100,000 cores. That's actually a true example that we did at Intuit. We did a machine learning algorithm that on a receipt, it finds where the total value of the receipt is. And surprisingly, it's not always the last value on the bottom right, because when you buy raw materials like lumber or something like that, there's some taxes that follow that number, a breakdown of different taxes. So that machine learning algorithm, the first proof of concept, was tens of thousands of cores, something like 70,000 cores. But once we productized it, we brought it down to less than 900, like 880 cores, something like that, right? And that was much more manageable from a cost perspective. So engineers are highly encouraged to experiment, but that responsibility, that freedom comes with a responsibility, right? You also need to monitor your cost and make sure that you're not over. So, for example, when, in my experience, when an experiment is unsuccessful, the engineer will terminate that experiment as quickly as possible, right? They don't want anyone to see that. But when the experiment is successful, they keep it up and running for weeks on end and show it around to their friends so that their friends can take a look at it, right? Meanwhile, this thing is 100,000 cores and costs us like, $10,000 a day or something like that. And this is where that, freedom and responsibility paradigm comes back. It's also part of the Netflix culture book, by the way, right? That the engineers get that freedom, but it comes with the responsibility that you need to act responsible, right? And that is a common theme. So we don't want, under no circumstances, do we want engineers to open tickets to start a new workload in the cloud, right? Maybe for an architecture review, that's okay, but they can just go and experiment as much as they want, and we don't want to constrain that, because the outcome of those experiments, and I see a lot of new stuff that is possible in the cloud, like bots, chatbots, and similar things that are very useful, that building this technology in the data center, it would be just a headache, and in the cloud, it's just a few mouse clicks and you're done, right? So under no circumstances do we want guardrails, right? These guardrails, if an engineer steps over, it either lets them know, a notification, right? You just started a service that is $5,000 an hour. Are you sure you wanted to do that, right? Or we push them back from the guardrail. So it's a little bit like a rubber band, right? That the engineer runs into it, but we push them back and said, like, you just started a virtual machine in the cloud that is $5 per hour. Usually the price is in single-digit cents, right? So we terminated that instance, and here's why. Here's a link to a Confluence page that explains how to do that properly. And if you did that intentionally, here's the steps that you can follow to do that. So we want those guardrails in place to let the engineers go on a paved road, but we don't want them to get hurt or them to hurt the company.